Smart parking system is an IoT-based parking solution that uses sensors and cameras to identify the availability of parking spaces in a given region. To begin with, sensors are embedded in parking spots to identify the parking slots are available or occupied. The collected data is thereafter sent in real time to a smart parking mobile application or website, which notify the users of the availability of parking slots. A camera can also be fixed at the entrance to capture the car plate for further use, such as tracking duration of parking and calculate payment amount. Smart parking systems are critical component of the smart city ecosystem. It is an approach that smart city can employ to boost the parking efficiency and address a variety of issues. Furthermore, smart parking has the potential to tackle the problem that users confront in traditional parking system while also benefiting the city and environment. Driver can save a lot of time. Instead of turning around looking for an available parking spot, it is directly improving the driving experience and reducing the frustration that a person may feel when looking for a parking space. Furthermore, smart parking can reduce the amount of fuel used when finding a parking slot, results in less greenhouse gas emission as well as less pollution to the environment. Aside from that, the smart parking system offers an easier form of paying, such as auto payment or ticketless payment.
In 1886, it is considered the birth year of the modern car. Automobile mass manufacture was well started in France and the United States by 1900. There will be no smart parking if vehicles did not exist. For the first time in 1920, forerunners of automated parking systems (APS) arose in major American cities such as Los Angeles, Chicago, New York, and Cincinnati. Between 1940 and 1950, the United States constructed an increasing number of automated parking systems, some of which are still operational today. In middle of this, a ticketing machine close to the checkpoint can be used to enter the parking garage. In the early 2000s, smart parking sensor technology began to gain traction, particularly in malls and retail centers.
Hi, I'm Nishan. I will continue the presentation for the future trend of the parking system. So obviously, the future trend of the parking system will implement the IoT to improve the efficiency of the car parking. And the car park will be installed by many IoT devices and also sensors. And all of them are connected to in order to enable the communication between each other. So the reason why we are applying the IoT in the car park is because it managed to bring the significant impacts and easing the car parking space problem for the traditional car parking system. And for instance, the drivers manage to check whether there's still parking space available in the parking lot by looking at the smart signal light, and it saves out a lot of time in searching for the parking space. So due to the help of the sensors and also the IoT device, the parking lot will only allow the vehicle to go in when there's a parking space is available. And the next will be the automated parking system. And this automated parking system is actually already existing in some of the countries, and it not only improve the parking efficiency as well as also reduce the space for the car park. So the vehicle will move to a platform, and then the platform will lift up and store the vehicle into a space. And this parking system is equipped with the automated storage rack to store their vehicle inside. And by applying such technology, we are able to allow more cars to park inside into the car park. And the self-driving car and also or the automated vehicle, what we so-called the automated vehicle, will also be a trend in the future due to its capability, and is capable to park itself with the help of the automated parking assist technology. And this car can move close to each other and significantly reduce the space that needed for the parking lots and the parking lots is able to contain more cars.
My name is Untitled. Then now I will proceed to the problem statement part. Then we discovered that the Malaysian mall parking system is inefficient and that malls lack a smart mall parking system. At the same time, the traditional mall parking system is producing few of the issue and challenge for the customer. The first problem statement is that paying a parking ticket takes a long time. There are only few ticket machines in some malls, and users who are unfamiliar with this place also may feel difficult to find the ticket machine, and the user must also wait for their turn to use the ticket machine. It will waste a lot of time, especially on weekends. Some ticket machine in the mall do not take the e-payment and only accept the cash. It will be inconvenient for the customer who prefer the cashless payment. And the second problem statement is that the customer wastes too much time seeking for the available parking place. Then this situation occurs frequently, causing the many individuals to avoid going to the mall due to the difficulty finding the parking space. Even when the parking space are fully occupied, the barrier still permits the customer to enter the parking lot. Then in the traditional mall parking system, there are no warning that there are no available slots for the user. Every minute a customer spends looking for an empty parking place is one less minute they can shop. The more time they spend in the parking lot, the less time they can shop. So it will cause the more revenue drop, and both customer and the mall will be affected. Then that's all my part. I will pass to the next person.
Right, so we will continue for the objective and also the proposed solutions. So our objective of this project is to develop a smart parking system by adopting the devices and also sensors and the service to improve the efficiency of the car parking and control the traffic in the car park. So this system is meant to be built for replacing the traditional car parking system due to many related problems and also inconvenience. So in this project, we will be choosing the Amazon Web Service as our platform to build this smart parking system. So the parking system is provide the features of checking the availability of the car parking space, automatically car plate recognition, recommendation of the car parking areas, and generating invoice and also the auto payment for the parking fees, and generating the reports from the parking lots data. So we are applying the AWS core to connect our devices and also sensors such as the smart camera, car sensor, and the barrier. And the barrier will only open when there's the parking slot is available in the car park, and the sensors will detect the presence of the vehicle, and the smart camera will then capture the car plate image. And the car plate image will then be retrieved from the temporary storage and analyze the car plate number and then store it into a database. And the system will update the timestamp for the particular vehicle enter and exit the shopping mall car park. So an exclusive and application will also be developed to allow the user to register their vehicle and provide the features of checking the car parking space in the building. And the available of the parking space will also be updated in real time so that the drivers will be able to know which parking area should be headed, which parking area there's parking space still available. So with the help of these features, it increases the speed of the drivers to search for the parking space. And besides, the application also have the capability for the user to make the auto payment and also generate invoices. Also, since we are adopting the Amazon Web Service, we will also use it to do the analysis and study on the peak hours and also the least hour by using the data that we collected from the database. So by doing that, we may organize the event, to attract the customer to the shopping mall.
Then now proceed to the comparison of the IoT platform. In here, we compare the three cloud service. The first is the Amazon Web Service AWS IoT platform, and the second is the Alibaba Cloud IoT platform. Then the third is the Google Cloud platform. Then in here, we will compare based on their cost and the price, benefit, then coverage, strength, and weakness. Then the Amazon Web AWS pay as you go model and pay less by using the more. Then the Alibaba is similar to the AWS, but it's less expensive than the AWS for the 1 month subscription, while AWS is cheaper for long-term usage. And the Google Cloud platform is more affordable among the three. Then 20 plus products are free for monthly usage limit. And the benefit is the AWS free trial and 12-month free trial for the certain service. And the Alibaba is free trial up to 12 months. And for the Google Cloud platform, 300 credit for the 90 days to the new user and 20 plus products which are always free. And for AWS, there are 81 availability zones in 25 regions, and the Alibaba have the 63 availability zones in 22 regions, and the Google Cloud has the 73 availability zones in the 24 regions. Then the strength for the AWS, it is the most cloud products provide high transfer stability, high data availability. For the Alibaba, hybrid capability and provide the highest number of service. Then for the Google Cloud, most offer service are open source, they're well documented. Then for the weakness in the AWS, expenditure may be high if properly managed. Then for the Alibaba, low ratio of the availability zones compared to the other providers. Then for the Google Cloud, the services are not as complete or fully packaged. Then now we will compare their service based on the different function. Then for AWS, they provide the IoT Core, AWS Lambda, and the DynamoDB for storage. Then for messaging, it provide the XNS. Then also provide the data pipeline for the data integration, and AWS Amplify, and Amazon Connector for the login user. Then Amazon QuickSight and Amazon Simple Storage Service. Then Alibaba Cloud provide the IoT platform, Alibaba Cloud Function Compute, Cloud Table Store, Cloud Message Service, Alibaba Cloud Data Integration, Alibaba Cloud Backend and IAM, Data Lake Analytics, and Alibaba Cloud OSS. Then the Google Cloud Platform provide the Cloud IoT Core, Google Cloud Functions, Google Cloud Data Store, and the Firebase Cloud Messaging, then Cloud Data Fusion, the Google Firebase Identify Platform, Google Data Studio, and the Google Cloud Storage for Firebase. Then that's all my part. I'll pass to the next presenter.
Firstly, the camera will capture the car plate number. After the car plate number is captured, then the barrier will open for the customer to go inside the mall parking. The sensor are used to monitor whether the car park slot is parked by any customer. AWS IoT Core creates smart things that can capture car plate image and send data to the storage. The AWS IoT device SDK is used to connect the things to AWS IoT Core and implement MQTT protocols for message exchange. AWS IoT Core allows you to connect device and sensor to AWS service or other device. IoT Core able to secure data during communication and interaction of device. It provides multi-layer of security and data encryption to the communication of device. Next, capture car plate number image to be stored in the Amazon S3. The Amazon S3 is an object storage service with the advantage of industry-leading scalability, data availability, security, and performance. After that, AWS Lambda will be used to retrieve the captured car plate number image from S3. Then call the recognition API to detect the car plate number in the image. Amazon Recognition is a service that allows developers to easily add trained or customizable computer vision APIs to their application without having to construct their own machine learning models or infrastructure. Furthermore, the number and sums, just such as timestamp, date, record ID, to be stored into DynamoDB. In sum, AWS Lambda is a computer service that allows developers to run the code without provisioning or managing the server. AWS Lambda can automatically handle function code to carry out certain events in the Lambda runtime environment. Developers can treat it as a back-end service to run the code and perform the events virtually. Furthermore, Amazon DynamoDB is a fully managed and serverless cloud database storage service from Amazon. It is well known for its fast and flexible NoSQL database service, which delivers the performance in single-digit milliseconds at any size. Moreover, DynamoDB secures the data with encryption, automatic backup, and granted reliability or service level agreement. Besides, DynamoDB allows users to export data tables to Amazon S3 by utilizing AWS data pipeline. By interacting with other AWS services, the data may then be analyzed, insight, extracted, and monitored.
Next, Amazon Athena and Amazon QuickSight is used to access and visualize data from multiple data sources. Amazon Athena is a federated query editor that enables the user to directly analyze data stored in Amazon S3. Developers can also query the data in place or extract from multiple data sources using SQL and store them in Amazon S3. Data in JSON format are fetched from Amazon DynamoDB to Amazon S3 and later to Amazon Athena. After querying the data, they can be visualized using Amazon QuickSight, a powerful visualization tool provided by AWS. Multiple Athena data sources can be joined together by adding the catalog and table using appropriate join configuration, such as inner join, left join, right join, and full join in Amazon QuickSight. In the development of mobile application, Amazon Cognito helps us to authorize end users to access the React application. This provides simple user identity and data synchronization services and allow the users to sign up or sign in using their credential or using the third-party authentication such as Google and Facebook. Next, we use AWS Amplify to create a new React application for this project and connect the React application to the GitHub repository. AWS Amplify provides a set of tools and services that can be used to build web and mobile applications. Developers could deploy and develop their website or application in just a few minutes and deliver a reliable, quality, and stable application using AWS Amplify. Next, Amazon API Gateway is a service that could assist the developer by providing service for creating, publishing, monitoring, maintaining, and securing REST, HTTP, and WebSocket API at any scale. We can create API that access AWS or other web services, as well as data stored in AWS Cloud. Last but not least, Amazon AppSync is used to retrieve and update the real-time record, such as available parking area, to the front-end app. It is providing a strong, scalable GraphOL interface for developers to aggregate the data from numerous sources, such as AWS Lambda, Amazon DynamoDB, HTTP API, and more. It is just as simple to add cache to boost performance, support real-time update, and client-side data storage to keep offline client in sync. The benefit of using the Amazon AppSync are simple and create data access, built-in real-time and offline capability, and no server are required to manage.
Hi, I'm Mission, and now I will be doing the demo for the AWS IoT Core and also showing how we are going to send the message from the AWS IoT Core to the S3 bucket. So first of all, we have to create things, and this thing we already created is called the smart camera. And what it will do, it will send the message, the timestamp of the car entering the parking, the car park, and also with the car plate image to the storage. So we will use the MQTT test variant to monitor our MQTT message that passed into the account. And then this is the Python script that we write for to send the timestamp and also the car plate image. And we have to connect our endpoint and also the client ID. And this client ID is actually the things that we created just now. Yeah, this one, the smart camera. And then this is the path of the certificate and also the path for the private key. And this is the path for the root.ca file. So this is the topic that we are going to subscribe and publish it to monitor the message that pass in. So the message will be containing the timestamp and also the car plate image together with the car plate image. So let us start to try this IoT Core. And first of all, we will going to subscribe a topic car detect camera. The topic already mentioned just now in the Python script, and then we will be using the CLI to run the Python script. So first of all, we have to change the directory, and then we run the Python script. that is beginning to publishing. Okay, so the message the topic is successfully published, and now we are go back to the AWS console and we can check. Yeah, the message is already passed in, and then we can monitor this message at here. And then now if we go to the S3 bucket, we will see this message, and we also with the CarPlay image. So this is the S3 bucket that we already created, and this one will fetch the data that sent from the IoT core. And this is the data that we just now that sent to the S3 bucket, and this one will be the CarPlay image. Let's download it and take a look at it. So so this is the data that we just sent, and also this will be the CarPlay image. Yeah, this is the CarPlay image, and I think that's all for the demo for the AWS IoT Core. Thank you.
So firstly, we should create an IAM role in order to access the DynamoDB and the S3 bucket, also used to trigger the Lambda function. So inside this role, the permission will be the DynamoDB access, the cognition access, and the Lambda execute. Next, the image will be stored inside the S3 bucket, and this is the S3 bucket created, and these are the image stored. Next, this is the Lambda function that we create, and here are the calls. The recognition API will be called, and the text detection function will be used to detect the casted number in the image. And this is the S3 bucket name and the image name. And this part of the code is used to display the result. Now we test. And this is the casted number detected. And this is the image that we use. So the result is totally the same as the detected. So after that, we will need to set the result inside the DynamoDB. So we have to uncomment this part of the code. And deploy. And so now we can go to the DynamoDB to check whether our result is added successfully or not. So this is the DynamoDB that we create. And export to the items. Yes, this is the record that we add, and it's successfully to be added inside the DynamoDB. So now I will show the result. This is the result, the record ID, the timestamp, and the detected casted number.
Now, I'm going to demo the Amazon Athena. First, you can search in AWS console and select Athena. Next, we need to make sure that the return chosen in Athena is same as what is chosen in S3. Next, you can click on the Create drop-down box and select S3 bucket data to create a table from S3 data source. Next, fill in the table details. If there is an existing database, click on the Choose on Existing Database radio button and select the database. If not, click on the Create a Database radio button and fill up the database name to create a new database. Next, we can click on Browse S3 to select the location of input dataset. After that, we need to change the data format to JSON and click on Create Table button. Now, you are navigated to Query Editor. You can click on Preview Table to select the top 10 rows of data. SQL query can also be typed in the Query Editor and click on Run. The result will be shown below the Query Editor. Next, I will demo Amazon QuickSight. Firstly, we need to select the QuickSight in AWS console, and then make sure that the region chosen in QuickSight is also same as what is chosen in Athena. Now, click on New Analysis to create a new analysis. If there are existing dataset, you can select it. Else, click on New Dataset to create a new dataset. To create a new dataset from Amazon Athena, we need to click on Athena button, and then fill in the data source name, and click on Create Data Source button. Next, we can select the database and also the table. After that, click on Select. Next, select the radio button, directly query your data, and click on Visualize. So now, we can choose the desired visual type and drag the attribute to X-axis and also the value column. The line chart will then be created and show on the screen. We can save, export, or share the visualization graph as well. This is the graph I came up with for this project, and the first one is the horizontal bar chart showing the number of vehicles on different day of the week. We may conclude from the bar chart that The days with the most vehicles entering the parking lot are Friday, Saturday, and Sunday, while the occupancy of parking lot peak on Sunday. From Monday to Thursday, the number of vehicles accessing the parking lot decrease. The second bar chart is presenting the data on the number of vehicles entered in different sections of the day. We can see from the bar chart that fewer vehicles enter the parking lot every night, especially on weekdays, and the number of vehicles on the other hand increase at noon on Friday, Saturday, and Sunday. This seems to suggest that some area of the car park could be closed throughout the week and only open on Friday, Saturday, and Sunday to save some resources. Furthermore, more marketing staff can also plan some activities or events to boost the revenue from Friday to Sunday midday, since this period of the time have most customers.
And now I will demo the Amazon connector. Then for the connector, select the manage the user pool, then select the amplify, select the create that you create, connector that you create. In here we can set which the attribute we require to retrieve and require the user to input. In here I require the attribute is email, then you also can set other attribute. Then in here also can set the minimum password length and set the it require the number, require the special character, require the uppercase or lowercase. Then this is for the other setting for the Amazon connector, and I set as default. Then now proceed to the AWS amplify. And in the more smart parking system, I host the environment to the GitHub. And this is the GitHub I host with it. Then in here, this is we can change the code by changing the src and the app.js. In here, this is my code. Then in here I put the hello from the G24. Then this is the example interface of the React app. Then in here we can change the code. Editing is simple. Then after that you can commit the change. Then normally it needs some time to build up the system. You can see that it starts to build the environment. Then we proceed to the next. Then we will proceed to the API gateway. Then this is the API gateway. Then before API gateway, we will proceed to the AWS app synchronize. Then this is the app synchronize that we create. Then in here we can connect it with the iOS application by copy this code. Then in here we also create the data table that you can retrieve and synchronize with the apps. Then now I will demo the API gateway. Then this is the API gateway that I created for by using the API we can add the new item to the DynamoDB. And in here we also set the route, and this is the route I set. Then I also set the integration the route with the AWS Lambda. Then this is the function that I set. This is the code of the function. In this code of the function can help to get the item from the database and create the new item and delete the item in the database. This is the 4 function that I create. And then this is the now I will demo how to create a new item by using the API gateway. Then this is the table that will set the item. Inside the table it has 2 items it's showing here. Then now I proceed how to insert a new item. In here I will just copying this API endpoint and put it at the end. Then in here we will put the ID and the name. Then just copy this whole line and paste in the backslash. Okay, then we proceed to the table. Then we can see that the new item is added in here by using the API gateway. Then that's all for my demo part. Thank you.